In this video, we're going to look at performing a linear static analysis. So after we've generated our model, applied our loads, we would then want to run a linear static analysis to be able to look at the results. So the process would work as generating the model, building our beams, our columns, anything else that needs to be constructed, and then applying our loads. We then need to save the file as a TEL or TEL file, and then we can perform an analysis. And we're going to look at doing this with this model that we've been working on in the last few examples. So in this model, I've already created my members, the joints. I've assigned properties like section properties, materials, supports as well. And I've applied loads, so I have several different load cases and 2 load combinations, and each one of those load cases also has loads within them. So at this stage, I can say that I am satisfied with the generation of my geometry and my loads, and I can go ahead and actually run an analysis. I'm going to press this Analyze button, which is the 4 dots that are kind of in a staggered order, or I can go to Run and then Analysis. And this is going to open up another dialog, and this will open up and allow me to choose what type of analysis I'd like to run. Depending on the edition of S-Frame that you own, you may not have the option to run all of these analysis types. But we're just going to look at linear static analysis for now. And I can choose whether I want to run only my load cases, only my load combinations, or both my load cases and combinations. This might be useful if you have a large model and you don't want to have to run all of your load cases every single time, or all of your load combinations. Now, I would recommend before running an analysis that you check your model one last time. We actually have a button here within the analysis to type dialog. It says check model, and this will just run an integrity check on your model to check for common modeling issues like stray nodes or duplicate members, overlapping members, those sorts of things that could be hard to spot with the naked eye, but can have an effect on your model's behavior. So we built this tool to check for it. You enter your tolerance, which is the maximum distance between 2 joints before they're no longer considered overlapping. And we also have a member length tolerance, which basically dictates what the smallest length of member you can have is before it's considered 0 length. So you can check for all these, make sure they're all checked, and then press the search button. And S-Frame will run a search on your model and identify if any of these issues exist in your model. I didn't get any messages indicating that was the case, so I should be good to go ahead and run the analysis. I'm going to just press OK. And now I'll press OK again to run the analysis from this analysis type dialog. And on my other screen here, I'll just drag this over, we have what's called the solution trail. And S-Frame Solver will generate this solution trail and show us what the solver has done. It's gone through the analysis. It ran a linear static analysis. It went through load cases 1, 2, and 3, self-weight, live, and dead, and my load combinations 1 and 2. And if there were any issues, like I ran into an issue with not having my supports applied, or maybe I forgot to apply sections, or my model is just unstable, those would be reported here. And we have different solver diagnostic messages and descriptions to each one of those as well. We'll get into that in a later video. But for now, I can just press any key to proceed past this point to the post processor. And now I'm brought into the graphical results window. And in later videos, we'll look at how we can actually look at the results.